So, a very good morning to all of you. I hope I'm audible to you.
Yes, sir.
Yes, sir.
Yeah. Yesterday we start understanding the memory structure of PIC device. PIC is peripheral interfacing device, and we collected sufficient information about the program memory. Size of program memory is 2 megabyte. Every location is of 8 bit. To communicate with that program memory, we require address bus and data bus. The size of address bus is 21 bit and which is one directional, and the size of data bus is 16 bit which is bidirectional, and all that information we have collected about the program memory. On a similar line, yesterday we already discussed the structure of data memory. Data memory is 4 kilobyte. So this is, to be exact, 4096 different registers are clubbed together. Every register consists of 8 bit. So this is of 8 bit. So it is called as 4 kilobyte memory. And then to communicate with that memory by the controller, it requires address bus, data bus, and control bus. Control bus we haven't shown intentionally because there are two lines, just one line for reading process and one line for writing process. So that we haven't shown. But we have shown the address bus and data bus. Then we realize, depends upon the size of this memory, the number of address lines are 12. So this is a 12-bit address bus. And the data bus to dump the data or to save the data in that respective register and to fetch the data by the controller. We require bunch of 8 lines. That is, data bus is of 8 bit. So this is 8 bit data bus. Every line, address line is defined by a different name. So the first line is A0, the last line is A11. Total we have 12 lines. Similarly, for data bus, the first line is D0, the last line is D7. Total we have 8 different lines. And this structure is called as data memory. Up till this we have seen in the last lecture. Now we have to add some more points because the structure or the segregation are made in this data memory so as to easily access by the programmer. When we write a program, we should be able to access the program memory. So let us see how they have restructured the entire registers present in a memory. Total are 4096 registers. So I'm going to draw one map and define the address of first, second, third. Likewise, the address of last register will be defined in terms of the address bus which is present here. Let me draw at that side. So, so first of all, I will be drawing the address bus starting from A0 to A11. Let me see that. This is A0, A1, A2, A3, then A4, A5, A6, A7, A8, A9, A10, and last will be A11. So, this is what a total address bus starting from A0 to A1, A2, A3 up to A11. So obviously, the first address, the address of first register is nothing but all the 12 lines 0, like this, 0, 0, 0, write clearly, 0, 0, 0, 0. All lines are 0 means we want to communicate with the very first register in the map. I hope it's clear. If I want to communicate with the next register, only A1 line must be 1, other lines will be 0, like 0, 0, 0, 0, 0, 0, 0, 0, and so on. Similarly, to communicate with the last register in this entire map, all the address lines must be 1, 1. So this is 1, 1, 1, 1 in that way. So total, if I begin from all 0 to all 0, 1, I mean remaining zeros and 1, 0, 1, 1, 1, 0, 0, 1, 0, 1. In that way, when I reach to the last address, that is 1, 1, 1, 1, all 12 line 1, I can communicate with the last register. In between that, how many different combinations are there? Different combinations of 1010 should be equal to 4096. As I said, one line, two combinations, two line, four combinations, three line, eight combinations, four line, 16 combinations. So if we have 12 lines, we have 4096 different combinations, and those are nothing but the address given to individual register, and that should be unique. That address should not be transferable to any other location, any other register. So this is perhaps known to us. Similarly, we have discussed similar line we have discussed yesterday also regarding the program memory. Now what they have done, they try to segregate the entire 64, sorry, two, so 4,000 locations into number of banks, and they call that banks as a memory bank. And what they have done, they have formed a first bank of 256 registers. So obviously, every 256 registers are clubbed together, and that becomes one bank. So I have shown this is one bank, the bank which consists of 256 registers. Each one of them is of 8 bit. Again, one more bank which is of 256 into 8. Again, one more bank, one more bank. Likewise, the last bank which is again of 256 into 8. So, straight away, 4096 divided by 256. Baga, total 4096. Each one of them is 256. This is the bank 1, bank 2, bank 3. So such we have different 16 banks. So the first bank is known as bank 0. Second bank is known as bank 1, bank 2, bank 3, bank 4, bank 5. Likewise, the last bank is known as bank number 15. If I convert 15 to hexadecimal, it becomes bank F. So my first bank consists of 256, second consists of 256, 256, 256. Likewise, we have total 16 number of banks, and every bank consists of the registers 256. Each one of them is 8 bit. So entire map is divided into 16 different sections. This is first section, this is second section. Likewise, here we will get the last section of bank. In this first bank, there must be 256 different registers. So how many lines we require? Address lines we require. I repeat, one line, two addresses, two line, four addresses, 12 line, 4096 addresses. But now, if the bank consists of only 256 registers, I mean, the address lines are not equal to 12. Address lines should be equal to 2 raised to n should be equal to 256. Let me put it here. 2 raised to n is equal to 256. I got to know that n becomes 8. 8 लाईन्स मध्ये मला 256 डिफरंट ऍड्रेसेस मिळणार आहेत. कसे बरं बघा. First address is all 8 lines 0 0 0 0 0 0 0 0. Next address is 0 0 0 0 0 0 0 1. Next address is 0 0 0 0 0 0 1 0. Next address is 0 0 0 0 0 0 1 1. असं करता करता when I reach to 1 1 1 1 1 1 1 1, I can define 256 different registers in that bank. Similarly, the next address of this 1111 should be obviously 0 0 0 0 0 0 0 0 with the bit number 8 should be 1. करून बघा. इथे आहे 0. याचा नेक्स्ट ऍड्रेस आहे एक काय करायचं +1 केलं तर काय मिळणार आपल्याला 0 0 0 0 0 0 0. In that way, next address will be 0 0 0 0 0 0 0 1 0 0 0 0 0 0 0 0 0 1 0 0 0 0 0 0 0 1 1. असं करता करता लास्ट ऍड्रेस ऑफ सेकंड बँक इज 1 1 1 1 1 1 1 1. Again, in this particular map, I will be finding out 256 different registers. But the प्रत्येक combination ला, now this bit must be 1. Now what is the next address? Somebody please tell me. After this 8 1 1 1 1 1 1 1 1 1, what will be the next address? सांगता येईल? Let me tell you. The next address will be just when I add 1 in that, you will get 0 0 0 0. Here I add 1, it becomes 0 1. Now this is the address, first address of third bank. +1 1 0 1 1 1 0 0 1 0 1. In that way, if I move ahead, I will get the third bank as 1 1 1 1 1 1 1 1, and this will be 1 0. Here also I got 256. Here I am getting 256. Here I am getting 256, and so on. So in that way, if I move towards the last bank, the first address of last bank will be 0 0 0 0 0 0 0 0. Last address of last bank will be 1 1 1 1 1 1 1 1. But that time, this first address of nibble will be 1 1 1 1. Let me, here also I am going to find out 256 different locations. The address which I defined by this particular block, this is called as the address of bank. Okay? The bank's address काय होतं? ह्या पहिल्या बँकेमध्ये this addresses are changed. Perhaps for all the combinations, this first 4 digit must be 0 0 0 0 0 0 0 0 till the last address of bank 1, bank 0. Second bank, here आहे bank 0, bank 1. Bank 1 चा पहिला ऍड्रेस आहे 0 0 0, लास्ट ऍड्रेस आहे 1 1 1 1. त्या प्रत्येक ऍड्रेसच्या वेळेला इथला ऍड्रेस हा सेम राहील. दॅट इज 0 0 0 1 0 0 0 1. Bank 2. Bank 2 is having the first address all 0, last address 1 1 1. But then the bank address is 1 0 for all these. So starting from 0000. In that way, if I see the last one, bank number 15, the first address is 0000, last address is 1111, but the bank address is 1111 to 1111. So in that way, we try to define the bank. So this is known as bank 0. This is known as bank 1. This is known as bank 2. So for this is known as bank F. F म्हणजे bank number 50. Bank address. So bank address are given as this one. आपण जर बघितलं, now when I draw the entire map, I will get all the addresses sequentially, starting from 12 digit 0 to 12 digit 1. I'm going to get a complete map. Just think is like I just try to segregate the address of bank separately from the entire chart. So this becomes the address of bank, and these are becomes the register address which are inside the bank. Now if you see, this particular section is repeated. This is same, this is same, this is same, all they are same, all they are same, only now the banks are different. I mean to say that, suppose in a colony we have 10 houses, and in 10 houses, 5 members are residing. In each house, 5 members are residing. So total number of members are equal to 5 multiplied by 10. 50 members are residing in a colony. A colony consists of 10 houses, and in each house we have 5 members. So total in all we have 50 different 50 people are there. But then some are residing in a house number 0. Some are residing in a house number 1. Some are residing in a house number 2, house number 3, house number 4, house number 10. So house addresses are changed, but the members are same. So the bank addresses are changed, but the number of registers are same. 256, 256, 256, and so on. So that map is constant, if you see here, but then the address of bank is changing every time. Before I move to the further discussion, हे काय आहे हे समजतंय का? हो किंवा नाही?
Yes, sir.
Let me start the discussion. So this is what a data memory map, the mapping of all the addresses. The first address is obviously this one, and the last address is 12 bit 0 to 12 bit 1. But further, for simplification, the programmer, I mean the manufacturer has divided the entire map of memory into 16 different banks. Every bank has different address, bank 0, bank 1, bank 2. But in that bank, again we are going to get the same addresses for register. But still, we can allow a specific address to individual register, how it is. The higher address is 00H. High address is 00H. This is 00H. This is 00H. Of course, the addresses are same, but then the first 00H is from bank 0. Second 00H is from bank 1. Last 00H is from bank last. So in a way, total bank address plus register address makes you a complete address, and that should be unique. So even though we can see repeated addresses in this section, Still, the banks are different, so always we are going to find out the net address, which is a combination of address of bank plus address of register. We will find the unique address for individual register, and that is the clause, that is the requirement of that. Okay, so this is the address. I am talking about this particular section. The address writing in a 8-bit binary is quite a lengthy one. Why should not convert to hex address? So hexadecimal address of the very first register is 0H0H, that is 00H. And the last address is 111, FFH. FFH. Here we got 256 registers. One more time. Bank number one. The first address is 00H. Last address is 11, sorry, FFH. This is 00H. Last is FFH. But the bank is different. This is first address 0H, second address 0H. Last address is FF. Again we obtain 00H to FFH. But now the bank is bank 2. On a similar line, if I discuss about the last bank, this is 00H, last is FFH. I will get 00H to FFH, but the bank is last. So, bank address with the address of this will give you a unique address for every register. Otherwise, this looks same. The map is same, but then the banks are different. Okay, I will give you some time to complete the chart. हे लिहू नका वाटलं, पण जे लिहिलं इथे बोर्डवरती मी ते पटकन लिहून घ्या, because this will carry 5 marks. I mean 5 marks we have discussed yesterday. Now we are discussing 5 marks. So this one and the map is extremely essential. Address bus. हा आहे ऍड्रेस बस आणि हा आहे बँकचा ऍड्रेस. बँक ऍड्रेस हा पण एच आहे ना, बघा ना, 0H, 1H, 2H, 3H, 4H, 5H, 6H, AH, BH, CH, DH, EH, F. This is F, FH. So bank address is hexadecimal address. हे आहे binary format, हे आहे hexadecimal address. I'll give you some time, just some seconds, maybe 60 seconds or 1 minute. Just complete it. I'll come back to the next content. Yet we haven't finished up this. This is a bit complex one. Okay, is it over? Shall I move ahead?
Yes, sir.
Yeah.
Yes,
Thank
sir.
you. Just we have seen a data memory consists of 4,000 locations. Then that is subdivided into number of banks. Every bank consists of 256 registers. Each one of them is 8 big. Accordingly, we will get different 16 banks because 16 multiplied by 256 is 4096. So that is quite obvious. And the names are given like bank 0, bank 1, bank 2 up to bank F. And then if I want to find out the net address of one of the register, I repeat, if I want to find out the net address or the last address, not last address, the final address of one of the register out of these 4,000 different locations, I will combine the address of register along with the address of bank. त्या registerचा address plus bankचा registerचा address असं मिळून जे मिळेल that will become a 12-bit unique address. हे तर sure आहे. So what they have done further, they try to form one more bank and the bankचं नाव आहे Axis Bank. It's not like AXIS, Axis Bank that we used to transaction of money transaction and this one. No, it is to access. Access means to communicate with that particular bank. The different name is given. The bank name is Access Bank. But all the banks are there, no? 0 to 16, 15. 16 banks are there. So one more bank is formed and that bank is known as Axis Bank. आता जशी बँक 0, बँक 1, बँक 2, बँक लास्ट ह्या आहेत ना, every bank consists of 256 registers. Similarly, this Axis Bank is also consist of 256 registers. This is also consist of 256 registers, each of 8 bit. पण आता माझ्या पूर्ण मेमरी मॅप मध्ये 4096 रजिस्टर्स आहेत. And all the registers, some of them are in bank 0, some of them are in a bank 1, bank 2, bank. So entire 4096 registers are either in one of the bank. So from where I should get these 256 banks separately, because no separate registers are present, because 4096 registers are divided either into number of banks. So if I want to find out these 256 registers, now these registers must be from the same bank. What the manufacturer has done, he tried to split bank 0 into two halves. So it tries to split bank 0 into two halves. One is this one, and other is here. So if I divide 256 into two halves, I will get 128 registers. So they have taken 120 registers from bank 0. Then what they have done? They splitted this last bank, bank F, into two halves, each of 128. Here it is. So this is 128 into 8. This is 128 into 8. Total bank 0 is 256. This is 128 into 8. Into 8 means 8 bit. And this is 128 into 8. Total is 256. Bank number F. We are discussing about only bank 0 and only bank F. Bank 0 मधले 128 registers, bank last मधले 128 registers. आपण जर क्लब केले, we will get 256 registers and त्याला म्हणतो आपण Axis Bank. So this first 128 registers are taken here. Just an understanding. So this is of 128 register taken from where? Taken from bank 0, first 128 registers. Last one. शेवटच्या बँक मध्ये शेवटचे 128 registers. आपण घेतले पुन्हा फॉर अवर कन्व्हिनियन्स, नॉट टेकन सेपरेटली, बट वी हॅव कन्सिडर्ड. So this 128 plus 128, we have got 256 registers. They try to give a different name. हे आहेत ना 128 registers, तर ते म्हणतात जनरल पर्पज रजिस्टर, GPR. It is not like, it is not government polytechnic Ratnagiri. It is GPR, जनरल पर्पज रजिस्टर. आणि हे आहेत ना 128, ते कुठने घेतले आपण? बँक लास्ट मधनं शेवटचे 128, त्याला म्हणतो आपण SFR, स्पेशल फंक्शन रजिस्टर. सो ऍक्सिस बँक कंसिस्ट ऑफ 128 जनरल पर्पज registers, दिसते कधी, and it consists of 128 special function register. So अशा प्रकारे GPRs 128, SFRs 128, GPRs are taken from bank 0, SFRs are taken from bank last. We have one more club, one more set of registers that is called as Axis Bank, and this is known as Axis Bank. Axis Bank consists of first 128 registers from bank 0 and last 128 registers from bank last. They are there, just we have taken separately just for our convenience, and that is called as Axis Bank. In short, they are GPRs and SFRs. GPRs are for general purpose, just for storing of data, and SFRs are for performing a specific task. Which task they are performing, I will let you know after this. Please draw this. Or other mention somewhere. If you don't have space, mention this content somewhere on notebook. That is called as Axis Bank. So Axis Bank is not separate bank. Axis Bank is not separate bank like bank 0, bank A. पण हा एक कन्सेप्ट आहे. त्या कन्सेप्ट मध्ये बँक 0 आणि बँक लास्ट मधले 128 रजिस्टर घ्यायचे, त्याला म्हणायचं ऍक्सिस बँक. बँक 0 मधनं जे घेतले आपण त्याला म्हणतो आपण GPRs, अँड बँक F मधनं घेतले त्याला म्हणतो आपण SFRs, स्पेशल फंक्शन रजिस्टर्स. काही डिफिकल्टी आहे? See, you are in a third year, so you will have to respond to the questions.
No, sir.
Answer
No, sir.
right, wrong, right, wrong answer नसतं. Right answer द्या फक्त बस. It may be wrong. Respond it. Otherwise, from next lecture, I will start turning on the videos. This one, your camera, and I'll ask you to show the notebook. Don't ask me to take some harsh decisions, please. Because I know that some of the students are joining the meet and they do not attend the lecture. That I know, but fine. Okay, have you got this or not?
Yes, sir, got it.
Yes.
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 Yes, sir.
Yes. Okay.
Yes, sir.
Yes, Savant, Wadkar, Shreyas, Mahekar. Good, good, good. Yes, yes. Okay. Now we'll write some points and then I think we'll stop this discussion. Point number one. It is a random access memory. Note down. What is the function? The function of memory is to store a data. It will not store any kind of program. Neha Nachankar. Right now she wants to join the class. Why should I allow her? Anyhow, to store data temporarily. Total size of memory is 4 kilo. To be exact, 4096. Consists of 4096 registers. The entire map is divided into 16 number banks. In memory banks. The first bank address is bank address is 0H2 FH. The first bank is 0H binary मध्ये 0000 आणि F म्हणजे 1111 binary. In a hex it is 0H to FH. Total we have 16 banks. Each bank consists of 256 registers. Consists of 256 registers. The concept of access bank. Access bank consists of 256 registers. It is divided into two sections, 128, 128. First 128 is called as GPRs. Last 128s of bank access bank are called as SFRs. These are taken from bank 0 and these are taken from bank F. So Axis Bank is not separate bank. It is one more restructure. I mean, yes, restructure of the entire this one memory 4000 memory. So there are some points regarding data. Okay, wait a minute. Let me correct the attendance. But, shall we stop here? Had difficulty as well? Then please ask me. Otherwise, you can leave the class. I know it's a subject is a conceptual subject, so it is more difficult sometimes to understand. That is fine. So please don't hesitate to ask me the questions. Please ask me the questions. Okay, yes, if you don't have any doubt, you can leave the class.